Correct. I'll, last discussion, so we stopped here, so just I'll give you a recap like what we have discussed in a 5 minutes, so that we will go ahead and then during we'll go ahead and discuss the next topics that we have, right? So last time we discussed how SQL Server executes a query, right? So how the query executes select and update statements, right? Whenever a query triggers, whenever a query user executes, that will go and so different phases and execute the query and get the result set, right? So it will check that protocol layer. So in the protocol layer, application and the SQL Server, client and the client and the target should have the same protocol, right? So if source is using, if client is using TCP IP, server also should have the same TCP IP protocol to communicate, to give a handshake between client and the server, right? So you should have a same protocol to execute the query or connect to the SQL Server. Once the query is triggered, so it will be converted as a TDS packet, that is a table data stream package, and it will be sending to the server, and server will receive the TDS packet, that is our SQL Server will receive the TDS packet, and it will be converted as, it will be wrapping the TDS packets and converting the TDS network packets as a TDS network packets as a T-SQL event, right? So T-SQL event or SQL understandable event, and so that will be processed to the command parser. Command parser will parse the query and it will be sending to the query optimizer, and query optimizer, it will do a n number of so checks to get the better execution plan. Get the execution plan which is fit for that particular query, right? Query optimizer will check different phases to get the create the execution plan. Before creating, it will check whether the plan is already exist or not. So if the plan is exist, that plan will be utilized. If the plan is not available, the query optimizer will generate a plan. So in the process of generating a plan, query optimizer in the process of generating a plan, so it will be validating in a different phases, right? So either it is a trivial plan or it requires any indexes or statistics or parallel execution. So all these things it will validate and generate a plan for execution, right? Once the plan is generated, it will be sent to the storage engine, and from the storage engine, it will go to the buffer manager. If it is a select query, then it will be so getting the data from the data cache. If the pages are not available, then it will be picking pages from the data file and keeping in the memory and get the data, right? So that is how select query works. If it is any DML operation, then it will be going to parallel, it will be going to the transaction manager, and transaction manager will write that information into the transaction log file. Once the transaction log file is written, that is what we have a durability of the transaction, right? So then it will be writing into the data cache, and with the help of checkpoint, the pages will be written to the data file. Written as in like the pages still would be available in the memory, and just copy the pages and return to the data file, right? So checkpoint does two things. One, it will write whatever lock cache. So we have internal memory, I told you, right? There is a one more lock cache, whatever transaction we perform, so that will be written to the lock cache to make sure that we are not doing excessive write operation, right? So it will, as soon as the lock cache is full, it will be written to the entire lock cache into the transaction log file. So checkpoint does two things. Whatever, as soon as checkpoint happens, whatever data we have in the log cache, it will be flushed to the log file, and whatever data we have in whatever modified or dirty pages we have in the memory, that will be flushed to the data file, and marking these pages as a clean, right? So but pages will be still available in the memory, so for the later usage. So if there is any memory pressure or any memory, so any other process requires memory, that is your SQL queries requires memory in example, and the pages in the memory will be removed by the lazy writer. Lazy writer will check whatever the, least recently used pages, and it will be removed based on LRU algorithm, and clear up the memory to release some space to the other process within the SQL Server. This is our SQL Server architecture that we discussed. And we have already also discussed, this is the same query life cycle, and we discussed UMS, user mode scheduler, how the threads will be scheduled to execute on the SQL Server. Okay. We have discussed threads and process, and each CPU we will have a different, each CPU that is a physical at the operating system layer, and each CPU is bound to a one scheduler that is a logical at the SQL Server, right? So if you have 4 CPUs, we will have a 4 schedulers. Each CPU is bound to one scheduler. So whatever threads SQL is spawning, SQL is a SOS, SQL operating system. SQL will have its own wrapper to schedule the threads, right? That also we discussed. So whatever threads which SQL schedules, so those threads will be executed on its dedicated CPU, right? On its bounded CPU. For example, SQL has 10 threads. So each these 10 threads will be distributed among these 4 CPUs, right? In a round robin fashion. Suppose 1 and this 2, this 3, 4, right? Equally it will distribute, right? Next thread it will execute, next thread it will be in the queue, next thread will be in the queue, next thread will be in the queue. Likewise, it will be in the equal distribution of the threads, right? So if it has 3 threads, then these 3 threads in the schedule will be executed on this CPU 1, right? On this particular CPU 1. So it has its own queues, right? So to keep the threads in the particular queue. For example, can anyone tell me what is this? I will show you. Can anyone like this one we discussed, right? Can anyone tell me what is this diagram means, right? So what exactly it does, what meant to be, or if it is not, so this one. Anyone that last time, so I believe that you were there, right? So you understood the concept.
What's the question?
I mean, what? So can you explain this diagram for me? Last time we discussed like either this one or this one, like, so you have threads in its own scheduler on its particular CPU, and how that schedule works, right? So how SQL Server schedule the threads, right? So this is how the basic or understanding, like how the threads will be scheduled and executed on the individual CPUs.
Go back to the diagram.
Sorry?
Go back to the other diagram.
Other diagram, okay.
Okay. So the pending mean that the trend is on pending. Like it's waiting, it's on pending.
Okay.
So the runnable mean that is available to run. Is available for the CPU, for the resources. Then running mean that is the current query that is running. So suspend is waiting for the OS IO, like it's waiting for the how will I put it? I don't know the best way to explain this one, but this one is suspend, it's waiting on resources.
Yeah.
So then the sleeping mean that these are the these are just open section that somebody opened, they didn't close. It's just a sleeping section. So it can be key. It's not doing anything.
Correct. Great. Yep. Thanks for answering. Thanks for so explaining that. That is absolutely right. Right. So if the thread, so if I go back here, so we have a multiple queues, right? So in each scheduler, you have these queues. So I heard like you were talking, right? But I cannot hear you. Your voice is too low. Like just check your so speaker. Like I couldn't hear you properly. Yeah, still. Please check your so mic, and then you can answer that.
You mean me?
No, it's Ion. The other one.
Okay.
Yeah, not you. Okay, so each CPU so will have these dedicated schedulers, right? So if I have two CPUs, these queues you will have, right? Each thread in one of these scheduler, or if not, then it will be in the, the thread will be not assigned to any of the tasks. That is your worker pool, right? Worker pool is where worker is nothing but a Windows terminology where we call it as a threads. So worker is nothing but a so the smallest so unit of thread, smallest unit of execution task, executor which executes our task, right? So if the worker is available, then a task is created that it will be picking the task and picking this worker, or assign the task to the worker, and will proceed with execution, right? Directly it will not execute and run on the CPU. What it will do, so before executing, it always will be in the runnable queue, to waiting for the current thread to give a signal, right? I was talking, right? The thread will be come out of out of CPU, and it will be giving signal to the thread which is in the runnable queue. It will be giving signal, right? So I'm coming out of CPU, you go ahead and execute on the CPU. So that signal it will give. So once it is receives the signal, then the thread which is in the first list will be going, header in the runnable queue will go and execute on the CPU, right? As soon as it comes out, and if it needs, so if it has to come out, then if it has to come out, it will be in the tail of the runnable queue. So it has to be in the tail of the runnable queue. If it needs some, if it has to work, if it again has to run on the CPU, then it will be going in the runnable queue. If it doesn't, and if the task is completed, then the task will be closed and it will be going back to the worker pool, right? So the thread will be available in the worker pool to get the thread assigned to some other task, right? So we have different weighted list IO. If the thread is waiting for some IO completion, right? So posted an asynchronous IO or posted some IO operation, and it is waiting for some IO, then it will be going to the IO list. Timer, suppose there are timer threads, right? So checkpoint, lazy writer, or you have scheduler monitor, or non-yielding scheduler monitor, resource monitor. These are the threads which are there in the timer list, and it will be every frequent intervals it will be going executing on the CPU. So likewise, we have a waited list. So if the thread is waiting for some, so if the thread is waiting for some resource, that is your, either it can be a lock, it can be a resource semaphore, or it can be a HID async commit, or it can be any wait, right? So IO, any backup thread or any wait, if it is waiting for, then the thread will be placed in the waited list, right? So all cannot be in the runnable list. So it will be having its own dedicated list in each scheduler, right? So if the thread is waiting for some resource, it will be waiting in the waited list, right? If the thread is in the waited list, or if the thread is waiting for some resources, then you will see a status as suspended. So where you will see, so you can say any DMVs that we have, sys.sys processors or sys.dm exec request, or even sp underscore who is active or sp underscore who to. So you query anything, then you will see that suspended because it is waiting for some resources, right? The status is suspended. If as soon as it receives that, so the wait request, as soon as it receives that wait resource, then it will go back to the runnable queue and executes its query, right? It will be in the end of runnable queue. So that same thing, IO and timer also, it schedules the threads. This is what it is, right? So you will see except this pending because the thread is not available and thread is not assigned. So it will not even execute the query, execute in the query. Execute in SQL Server. So you will not see except this pending. You will see runnable from the sys.sys processes, suspended from the sys.sys processor DM exec request, and this one sleeping. So sleeping is something which is open but not closed, right? Either the transaction is still open or the transaction is completed, right? So it doesn't matter, either transaction is open or transaction is completed, that session is not closed. For example, begin tran, let's say select start from person, right? So if I execute this, see, I am just executing without any proper closure, right? So I'm not closing, right? Either we should have commit or roll back the transaction. So normally we should have the commit transaction when we execute it, anything from the application, right? So application will be using the begin and close the connection. So if that is the case, the connections which are open should be closed. And if you see that the main, so as a DB developer, that you use main two DMVs. One DMV is select start from sys dot dm underscore exec request, right? So we know the session ID, it is 52. Let's go with that to filter the other rows that we have, right? So I'm just using the 52 here, right? People who are not, I believe everyone know. So this is the 52 session that I'm using, where session ID is the column in sys.dm exec request equal to 52. And if I execute, I don't say anything, right? This is not a executing session. So sys.dm exec request, you get only the execution sessions. Whereas if you open that, so if you execute the sys.sys processes, where speed is the column for session 52, right? So if you see here, this is the open, right? So this is the session which we have. So if you see that miscellaneous, because it is not waiting for anything, it is just, so staying and not doing anything. And if you go here, right? So status is sleeping, right? So status is sleeping. And if you see here, open transaction, this is what these two are important. If the session is sleeping, right? If the session is sleeping, if the transaction is open, that is one, then it is a open transaction which can impact other queries, which can block other queries as well, right? For example, I can roll back. Begin update person set first name equal to ABC, let's say, for example, whatever. Where no, not where, let it be, right? So I'm just updating this, and it is not, I haven't closed, right? If you see here 52, it is sleeping. Okay, it is not showing as open. So ideally it should show as open. So this is blocked. 52 in 52, 57, comma 52. Okay, so this is blocked, right? So 52 speed blocked 57. So that is what we see here, suspended, right? Suspended, and it is in sleeping state. So if you execute the some other query, anything, select start from person. Okay. So I just wanted to show while 1 equal to 1. So I just wanted to run that in a loop to show you different states that we have. 66. So this is a runnable queue. So that the query is completed and waiting for CPU. And if the CPU is available, then it will be going in and running the query. Suspended, right? It is waiting for some resources, right? So likewise, you see the query execution. So I'll close this. I'm rolling back the update query so that it will be not affected. Okay, so this is how you can check, right? So sys.sys processes will give a better insight, right? If the threads are open or if the sessions are open and not been closed by the application or not closed by the user, which are open, right? So that you should be able to identify from the sys.sys processes, but not from the sys.dm exec requests, remember. And also sys.sys processes will give a better result. I mean, better as in, suppose if you are executing a query which is running in parallel, right? So your query is running, executing parallelly. So how you will understand the query is, so running parallelly or not? So sys.dm exec request, you will not see that query is running parallelly or not. Parallelly or not. For example, so 66, 56. Sys.sys processes, where I'll tell you what is the parallel and all. Just I'll show you the difference between sys.sys processes and sys.dm exec request, because we frequently execute so these TMVs to get the data, right? Sys.dm underscore exec underscore request, where session ID equal to 55, right? So 55, if I execute, select star from select star from votes.
Hello, Chandu.
Yep.
Yeah, I'm audible.
Still a little low. Just check, and if not, that should be fine. So I can hear you, but it is a little low. But as soon as you hear me, then it should be
Yeah,
fine.
I can.
Okay, cool. So, but yeah, you check your mic before you talk, because I barely hear you. I can hear very low. Your voice is very low. Cool. So if I execute this and if I query this, so it is waiting for some async network IO runnable. I'm expecting to see. So I'm just executing. I'm executing sys.sys processes and sys.dm exec requests, right? So let's see. Page slash whatever. Guessing network IO. Bear with me. So I'll show you one thing so that you will understand the query optimizer whenever executes, right? So I was talking, it go for serial execution or parallel execution, right? So optimizer will validate in a different phases to check whether the query of the cost of the query is, so within the query cost or not. So it is not going here. Okay. Oh, okay. Wait, where ID equal to 100. Mm, okay. Where ID less greater than 1000. Mhm. Okay, fine. So I was not able to execute, show you that parallel threads, right? Suppose if the query is running parallelly, you see in the sys.sys processes, so you will see that multiple threads, all threads, but sys.dm exec request, you will see only one session, whereas so so the sys.sys processes, you will see multiple threads, and the sys.dm exec request, you will see only one consolidated session, right? Only one thread or one session. So you will see, and it will be so it will be showing the status and the metrics of that query, right? So that is what we have it here. So this is the high level design that we have. We get a request and it will be assigned to an idle worker which is available, and assign the request to the idle worker, and it will be placed in the runnable queue, right? If the worker is not available, check worker limit has reached and create a worker and assign to that, right? So if the worker is available, and if that worker will be assigned to a task, and the task will be execute on the CPU, right? So this is what we discussed. Okay, let's move on. So this is the high level performance, so cost map, right? So performance cost map, as in, let's say you have some request or from the application team, or you got some ticket stating that there is a performance issue, right? So as soon as they ask for they mentioned that there is a performance issues, right? So what is the what do you mean by performance issue, right? So we should ask more questions to understand so what exactly the requirement is, right? So I personally consider any performance issues is two ways, right? So one is server wide performance, so the second one is the query performance, right? So server wide performance is in overall server, we will have to investigate, or we'll have to investigate anything a specific query to find the find the cause for performance, right? So this is the high level. Suppose let's say there there is a performance issue, right? So if the performance issue, then we will have to check if there is any query specific process, or query or a specific process is slow. Let's say they are executing some job, either the job is slow, or they're running some query, or the query is slow, or the entire application is slow, right? So if the entire application is slow, so it doesn't make any sense, so we investigate and troubleshoot a specific query, because if you start investigating a specific query, that is not a correct path, because the other query is also slow, and in that case, so we cannot tell that a specific query is slow. So it can be either server level performance from the SQL server side, or it can be at the application level as well, right? So there could be an issue at the application side. So first, as a SQL engineer or SQL team, you will have to investigate from the SQL server side. If there is any notable issues you identify from SQL, then that is something that we will share. If nothing, then we will have to provide that information to the application team to validate from their end, right? So that is, there is possibility from the application and also the issues, right? So recently, I'll tell you just an example. Recently, we were working on one issue where, so we have from the application, they're executing the queries and we see hundreds of sessions which are in sleeping state, right? So hundreds of sessions which are in sleeping state. If the connections are open at the SQL will not close the connection automatically. Like suppose if it is an explicit transaction, SQL can anyone tell me like what are the types of transactions that we have?
Implicit and explicit.
Okay, so what is the difference between implicit and explicit?
Implicit, we don't mention. Implicit, we don't mention the begin and the commit part. It's automatically performed by SQL Server. But the explicit part, we have to start with begin and then do our other part, and then we finish it by commit or I guess.
Correct, that is correct. Thanks for that. And we have one more type of transaction is auto commit, right? So there are three types. One is implicit. One is implicit transaction. Implicit. Second one is explicit. Third is auto commit. Right. So most of the people like, so we mislead with auto commit and the implicit transaction that we have, right? So we so the confusion around, right? So the auto commit and implicit transaction. So explicit transaction, what you said, so begin run, and you will have to the query whatever you execute, and you will have to explicitly, if it is an explicit transaction, you'll have to explicitly provide either commit or roll back the transaction, right? So commit or roll back. We have another transaction called implicit transaction. Suppose if you use that implicit transaction, the connection has to be closed, right? You no need to open the begin tran, but if it is an implicit transaction, the connection is still be available. For example, so we can set that implicit transaction from the SSMS query options, right? So suppose if you go here, query and query options, execution and see set non-SQL parameter set and say statistics. Set implicit transaction, right? So if you enable the set implicit transactions option, right? So if you execute update ports, let's go with this adventure works, update update person where first name equal to ABC, right? So where first name equal to set first name equal to ABC, let's say, right? So these are all updated. So I have not even used this update. Oh, okay. My bad. This is the query basis. So set implicit transaction is per the session basis. So I have opened this set implicit transaction here and I'm executing here. That is what it is, the problem. Okay, let's see. Okay, so I ran this query, and if you open a session, another session, select star from person. right? So you see here, I have not executed any begin run, and I have not executed, it is not an explicit transaction, but this is a implicit transaction. So though the query completed, and you see that select query is not been processed. Why? And if you see that select start from sys.sys processes where speed equal to 59, right? 59 is being blocked by 53. So 53, see here, this is not a explicit transaction, but this is an implicit transaction, right? So if you see that 50 in 53 comma 59, so 53 is in sleeping state, but if you see that open run and it is in sleeping state, right? The transaction is still open and currently which is in sleeping, right? That is the reason it has been blocked. It is actually blocking the other session, right? And remember, this is not an implicit, this is not an explicit transaction. And based on our understanding, if it is an implicit transaction, it should be an auto commit. If it is auto commit, I mean, it should commit if you don't provide the begin run. But if you enable that implicit transaction, right? So that is one way, set implicit transaction on or something. Some query, set the implicit transaction on. Suppose if you have that, whatever, like the statement, that doesn't matter. So if you execute this, this is not a commit statement. Yeah, it is commit if you don't provide a implicit transaction on. If it is not a implicit transaction, then the commit, if it is an, then it is considered as an auto commit. If you don't specify, then we will have to check if it is a implicit transaction. So if that is the case, that transaction is open, and you will have to explicitly commit or roll back the transaction, right? For implicit transaction, you no need to use that begin run, but the commit or rollback should be explicitly provided, right? That is what implicit transaction is, just to open a transaction without a begin command, but the query will still consider as a open, and you will have to explicitly commit or roll back the transaction, right? Three types. One is implicit, explicit, and auto commit. Auto commit, and you're just executing and it will commit the transaction, right? If it is an implicit transaction, you no need to explicitly mention that begin run, but the commit or rollback should be provided explicitly.
Chandu,
Yeah.
how we will mention then what is our solution here if it is implicit
The
conversion?
connection should be closed.
We cannot close now. We should take the permission.
Yeah, that's what, right? Application has to close the connection. We cannot.
Okay, so we should
It is just like,
maintain.
it is just like a one connection connected and open in the SQL server, and application should take care of that.
Okay, okay, Chandu.
Question.
Sure.
So that means SQL Server is always on auto commit by default?
SQL Server will always auto commit by default. So no, SQL Server will not commit the transaction, right? So if you execute, I mean, you mean like if you are executing from the SSMS or
No,
SQL
no, no.
Server
My
tool?
question, yeah, my question is when we use this this query pad right here, I never had to do like begin tran or commit or anything, right? We usually just
You
type in
correct,
and run it updates, blah blah. So that means it's been usually SQL Server is on auto commit by
correct,
default.
correct. By default, it is
Okay.
auto commit. Yes. Unless and
Okay.
until you don't specify this hint that I mentioned, right? Set implicit transactions.
Right.
If you don't specify,
Right.
it is auto commit, but it is always suggested to use a begin run if you, even if you are executing from the SSMS or Data Studio or wherever SQL tools that we are using. Because what if you accidentally update or delete some transaction, right? So you can roll back
Right.
or revert the transaction.
Hello,
So
Chandu.
so it's always good to use the begin tran. So
Better.
that makes it explicit.
Correct.
So I'm gonna have to commit or roll back.
Roll back. Correct.
Right.
Yeah.
Correct.
Yeah.
Yeah, how will identify that?
Your voice is too low. How to identify what?
How we should identify the execution? So this is for the explicit conversion.
Okay, so we will talk that later, like execution queries. But again, as I was talking, right, DMVs that we have. So from the DMVs, you can get the execution, current running, long running query or current queries which are running. So we can find from the DMVs or even from the query store, whatever it is. We will talk that later. I don't want to, so add and confuse here. Yeah, we can talk later.
Okay.
Right. So here, let's move on. We have a performance and you'll have to identify any specific query which is slow or anything specific process which is running slow, right? So then once we have that, if the query is, then we identify that and we conclude that there is a specific query issue. If that is the case, we'll go with query tuning, right? So identify a statement or query. Let's say you are executing a batch, right? Or job. So job triggers multiple queries or multiple transactions within the so batch, right? Your batch is nothing but a multiple transactions or multiple queries in a as a group that you are executing. If a batch is running for 1 hour, so if the batch is running for 1 hour, so if you are troubleshooting the entire batch blindly, so then there is no point that there is no way that we can conclude an issue, or it takes longer. You would be able to find, but it takes longer. So what you can find, so in the batch you have two queries. Let's say, for example, query 1, query 2. You have two queries. So in this batch, I'll tell you here, begin run, for example. So update person.person we set last name equal to xyz. xyz. Let's say go. Then delete person.person from delete from where business entity ID whatever equal to 100. Go and select start from person.person, right? So let's consider these three queries you have in a batch. Let's say commit. So these three you consider as a batch, and any of these individual query can be running slow, right? So if the entire batch, this is the begin, this is the commit, this considered as a batch, and if the query is running, and you will have to identify which transaction is running slow. So based on that, we can conclude that a particular session is running. Any questions? Okay, I'll just put on mute to everybody, and if you have any questions, please ask and we can talk. Okay, so if in the batch, you'll have to identify which transaction is slow, right? So we will talk like how to identify in a batch. You have different methods to identify which transaction is slow in a batch, right? So extended events you can capture to identify which transaction is slow. That is one way. So you can execute, so profiler, but that is an expensive. So we will talk that later high level, but we always use that extended events. This is not that class for query tuning, and I'll move forward, right? So you'll have to identify the statements of the query. If the query is identified, then query tuning. So you will have to go with query performance. So I would say like query performance, either it can be tuning or it can be, tweaking some values to improve the performance, right? So we'll go with query performance. Suppose if you don't have a specific statement, that is what it is I have mentioned here. So either you can go with the DMVs, extended events, profiler, or query store, right? So you get the query of the long running transaction or whatever. So if not a specific query flow, then we'll check if there is any specific configuration needs to be changed. So we will talk that configurations.
I have a
And
question, sorry.
yeah.
So how do we identify which query is running slow out of all the out of all the queries in a batch?
Correct. So that's what I mentioned, right? So we will talk that, but you have a
Okay.
different ways to identify that, right? So let's say, for example, you are executing a query. So if the query is running, so then each query, each transaction, you will have a different offset. So we will talk that, so each query will have a different offset, and from there you can find which query is running slow or what is the query, but you will have to capture some traces. So without traces, and if you are executing DMVs, from the DMV, you can identify which query is currently running. So I will show you that, so when we were talking. But to answer your question, if you don't know when the issue would happen, let's say, for example, every day the issue would happen, but we don't know exact time. If you don't know that time, and if you want to investigate the issue, you can leave that you can leave that extended events or query store enabled, so that you will have that query particular statement which is running and taking more time to execute. Or if you know that execution, if you know the time the query executes, that query you can find from the DMV sys.dm exec request, and by joining some other tables, and we can find the query which is running slow. So that is there. I
Okay,
will.
I have a question here. So that means in that case, right? Um, it's when you suspect that a query is running slow, which is appearing like a pattern, right? You can open either profiler, extended event, query store to track the next occurrence, right? But if it has occurred already, is there anything you can do to see what happened at that time?
So if it is a historical or the so past occurrence, so you can find from the query store. But if the future occurrence, so again, so if you don't know when the issue would happen, you'll have to capture that extended events and let it run, so for a day or two. So to identify, like at least a batch started or batch completed or statement start. I mean, we will talk that whatever extended events traces we'll have to enable, but you can capture that extended events to identify the issue if the issue reoccurs or resurfaces in the next execution, during next execution.
Okay, but the ones that have occurred already, you can use
If it is
query
already
store.
query store, yeah, correct.
What if you not enable query store? Will you still be able to get that? Because sometimes it's not enabled on our environment. Maybe it has happened. You now enabled query store, but do you think you can still get the past event, or going forward, it's whatever happens going forward that you can refer to query store to see?
Right. If you don't have a query store, it is tough, right? Because SQL will not capture everything, right? So if that is the case, maybe we can check that, so whatever we have in the plant cache, and see if anything, so useful information we get. So otherwise, so you will not have anything in the SQL cache which stores that information of the execution. If that is the case, then there is no point of having query stores and extended events, so profiler concepts, right? Like if SQL would be able to cache that information. But yeah, so unfortunately, we don't have that mechanism to cache all the statements by default. We will have in the plan cache, or we will have in the memory for certain time. So until and unless you execute the same query, or until and unless the plan is flushed, but that statement level plans also would be available. So we can identify from the plan cache itself. But you will not have more detailed information, like, so how the query, what was the waiting, what it was waiting for, and what was the runtime, and so duration of the query, wait time and all, you might not have that detailed information.
Okay, gotcha.
Yeah, but we will talk that.
Yeah.
If it is a
sorry.
query tuning questions, that we will have a detail. Yeah, if you have anything specific, let me know.
Yeah. As per what Felix just mentioned, in the case of if there is monitoring tool in the environment, is it not possible to capture the query runs, the duration, like historically, like for few days?
So we have an option, but so what I was talking, suppose if you don't have anything enabled and if you want to identify the past events, right, a past execution latency or execution events, that is something that it is tough, because SQL will not cache any of the transaction information in the memory for longer duration. So if that is the case, it is difficult to investigate the issue for the query performance. If the issue resurfaces or if the issue reoccurs, maybe we can capture that extended event session, so we can leave that extended event session open so that it will capture whatever data we require, or what if the issue reoccurs or if the query executes. And extended events, right? Extended events also, we should not execute on complete database, right? Instead of, if you have anything specific, let's say for example, query text, we have a select star from table name, right? So if you have a table name, you can filter the extended events on table name so that we will have only queries which are accessing this table will be cached, will be captured in the extended events, right? You'll have to enable that extended events and leave that extended events to capture the transaction, capture the statements which is running slow. But if you're asking that past events, that is tough, right? So we will not have that event available in the memory, or SQL Server will not cache those events.
I think it's possible if you have a monitoring tools.
Yeah, that
So
was my question.
it depends on what metric I've been setting up for that monitoring tools. So you can capture the
you are right.
historical
But
monitoring
he
tool.
said if you don't have anything set up,
Correct.
it's difficult. That's what he explained. Yes. So you are right, Femi.
Right, that is true.
I have a question. You use some of the DMVs. Can't you like set up the DMVs in a job, like a job, to capture some of these and store it like in a table? Okay.
We do. That is what, right? Like suppose I don't that is all, that's what I mentioned here, the capture, and this is not performance, so we will discuss that detail. But that is where, like, I don't know how many of you aware, like SP_, who is active, right? So this is a customized store procedure which I think like Brent Ojar or like, so I don't know who built that, but there is a SP_,
somebody Adam. Somebody Adam.
Correct. So he
Adam
created
Mechanic.
correct. He created the store procedure by help of DMVs, right? So he pulled that and it creates, if you use that store procedure, customized store procedure, so that will create a table and it will store, that will create, that will capture the data and store that in the database. So we would be able to get the data that you require, that you can do. So this extend events, it is a by default SQL Server tools that we have. So DMVs you can capture and execute, create on a table and get the data. That is possible. Yes. And to answer the first question, like if you have a, to answer to someone mentioned, right? So if you have a monitoring tool, definitely, right? So this is what I was talking, only if you don't have anything else, right? So if you don't have any captured, or if you don't have any monitoring, you don't have anything storing in the database or storing in any of the DBA databases, that is where we will not have any information. Suppose if you have monitoring tool, well and good, right? So you will have that information stored in the monitoring tool itself.
Hello, Chandu.
Sorry.
Chandu, this is Ayan.
Yeah, tell me, Ayan.
Yeah, Chandu, if we have an issue, then mostly in our organization, we will go and we'll check with the SP_Voto and the active monitor.
Okay.
So in that also we can identify the queries, right?
That's what, right? So if that is a running query, currently executing query, so you can identify from the activity monitor, or you can identify from SP, whatever DMVs that we have. If the query is completed, and if you want to investigate the issue, you will not have that information there.
Okay.
If it is a live query troubleshooting, that is a different story. But if you want to investigate or postmortem the query, then you will have to have some mechanism to capture that data.
Yeah. Actually, that is my question. Though I'm very difficult to identify the query if we have any performance issue. Please tell us that step by step.
I will talk that in the query performance. We will
Okay.
discuss.
Thank
Yeah.
you. Thank you, Chandra.
But if you have some tools, or if the data is captured somewhere in the database, so that is where you can query that data or table to identify the query. If you don't have anything, so I can help you to, so how to how to track or how to query, and how to identify whether this is a long running or this is not a long running query. So that I can help you.
Okay, Chandra.
Cool. So we'll move forward, right? So I was talking here, right? So configuration issues, there are possibilities the configuration itself is an issue, right? So let's say everything is fine, right? But there can be an issue with the configurations itself, right? So the system-wide configuration or database-wide configuration, or as per the best practices, we are missing something, right? So we will talk that, I will show you that high level, and we will talk in the going forward, right? The hardware and operating system considerations, right? So we should have a proper CPUs, and so even memory configuration and disk and network, right? These are the main thing that impacts the performance of your query. So it can be either a CPU load, right, number of cores based on the workload, or it can be a memory issue, or it can be a disk subsystem, or it can be a network. So this is not specific to anything, this is just a high level consideration that we have, right? Configuration wise, so you should have a proper CPU. Let's say, for example, you have only 4 CPUs, but you are executing hundreds of sessions, right? So if you are executing so high workload, or your databases are very huge, right? If that is the case, for might be 4 CPUs would not be sufficient. So you will have to check whether I require a more CPUs or not, right? So based on that, we will have to consider CPU, so increasing number of CPUs. At the same time, memory configuration, we require to cache the data in the memory. Suppose if you don't have a proper memory configuration, the pages will be flushed out and your queries will be waiting for memory to be available, right? So the same thing, IO subsystem, disk subsystem, whatever queries we are executing, and it has to go back to the data, go back to the storage and do some operations. Suppose if your storage is slow, then you will see some latency, or you will see a majority of latency if the disk is not available or disk subsystem is not proper. But we will talk that, don't worry about, so the metrics that we have, or the metrics we'll have to collect. So this is just a high level that I'm talking. What are all considerations when we go with so further investigation of the performance, right? So if the disk is subsystem is slow, so you will see that some IO slowness, right? The configurations wise, right? So you will have to make sure that SQL version and so the patch is up to date, right? For example, I noticed some issues, right? In past, because of some patch, like so because of some bug at the product, right? So SQL product, we noticed some performance issues, right? So one query was running, so taking most of the CPU, most of the memory, around 60 gigs of memory, right? That is waiting for some wait type, right? Which is not a noticeable wait type, but it is taking around 60 gigs of memory or more than that, right? So that is where we see some bug at the Microsoft product, and we'll have to make sure that the bug has been applied, the patch has been applied. So you'll have to make sure that SQL is latest version before even investigating further with the performance, right? It is not always, but you'll have to make sure that the SQL version and the patch level is up to date. Instant file initialization, right? So what is that instant file initialization? For example, if the query, if the, so if you install SQL Server and if you expand the database, right? So if you're creating a database or restoring a database, what will happen? So initially the file, let's say this is the file. So initially, whenever you create or whenever the database data file is created, so it will be marking all these files into a 0 file. It will be zeroing the complete file. Whatever size that we have created, it will be zeroing the complete file. And once that is completed, first it will be zeroing the complete file. Then whatever write we perform, so that will be writing this on top of this. Okay, the data will be written on this, right? First it will be zeroing the file, right? So it takes some amount of time, or it takes majority of the time to perform this zeroing operation, right? So this zeroing is an expensive. Let's say, for example, you have 100 gigs of data file, or even 1 terabyte of database file. If you have 1 terabyte of database file, then it will be keep zeroing the file, data file, and once that is completed, then it will be writing into the data file. So that is an expensive operation, right? So if that is an expensive operation, and it takes longer while restoring the database, right? If you are doing a restore, and if it is taking more time to restore, this is also one of the contributor for the slow restore of the database, right? You'll have to validate instant file initialization. So this is not only for restore and create, even if the file is expanding with auto growth, right? So now it is around 1 GB file and expanding to another GB. And the expansion, the other GB will be first zeroing, then it will be writing into the file. So to avoid that zeroing of the file, so we enable the instant file initialization. So instant file initialization will avoid the zeroing of the data file. Remember, it is only for data file, not for the transaction log file. Transaction log file is still perform the zeroing, but if it is a data file, that zeroing will be skipped, right? So how to skip that? How to enable that? You have a local security policy, performance volume maintenance task in local security policies, and you will have to add your SQL service account. Local security policies, right? So if you open that local security policies and local policies, user rights and assignment, right? Local policies, user rights and assignment, what is that? Performance volume maintenance task. Performance volume maintenance task, right? You'll have to add the SQL Server service account to the performance volume maintenance task. Add SQL Server service account, and you'll have to restart the SQL service, right, to affect this change, so that it will be avoiding the it will avoid that zeroing of the file, right? And just for your information, how to identify the service account which SQL Server is running, right? Let's say, for example, you are connected SSMS from a remote machine or jump server, and you want to get the SQL Server service account. So how to get the SQL Server service account without RDP to the machine? So we can get the service account from the DMV itself, sys.dm server services, right? So if you execute that, you will get the service account with SQL service or whatever services which are currently running on, right? So this is the service account. So get the service account and enable the performance volume maintenance task, right? What is the DMV? sys.dm underscore server services to get the service account. That is installed file initialization. LPM, locked pages in memory, right? So locked pages in memory also important, because if you don't enable these locked pages in memory, what will happen? We will talk more in detail, like when we talk about the talk in memory, but just a high level, I'll tell you. Let's say this is your SQL Server, and you have allocated around 10 GB of memory to the SQL Server, right? 10 gigs you have allocated to the SQL Server. This is your operating system. Now, I have some other application also. Let's say, for example, either it can be a notepad or it can be a PowerShell. It can be any application that I have some other process. Each application we call it as process, right? I was talking, and this is a SQL process. And this is some other process. Now I have around 15 GB RAM operating system. I have 15 GB allocated. I have allocated 10 GB. I have not enabled LPM, lock pages in memory. I have not enabled. Now what happened? SQL allocated 10 GB, right? It is a dynamic memory. Wherever SQL will be consumed, whatever memory we allocated, that is a different story. So I have a 10 gigs. Now some other process requires some amount of memory, that is require around 8 GB of memory. So 8 GB of memory, then it will be first taking from the Windows operating system, whatever available memory. Windows operating system available memory is 5 GB, because SQL allocated 10, total 15, and 5 GB is available. So the other process will take memory from the Windows operating system, whatever memory, like let's say for example 4.5 GB memory taken, and remaining 500 MB is for the Windows process, Windows internal process. It is using that, otherwise the entire server will shut down, right? So it will be using that 500 MB and allocated the memory, but it needs the other amount of memory. If it needs the memory, then what Windows operating system will do? So what is the highest memory consumer in the Windows operating system? It identifies SQL is the highest memory consumer. Then it will start trimming the SQL memory. It will be trimming the SQL memory, and it will be allocate that memory to the other process which is required more memory, right? This is SQL trimming because of external memory pressure. So we have the memory, we require memory, and SQL is trimming, right? But is it good practice to release the memory which is allocated to the SQL server? No, because we need more memory to cache our data pages and plans and all, right? To avoid this trimming because of some external memory pressures, we are enabling lock pages in memory. There is a lock pages in memory we enable to avoid the trimming because of some external memory pressures, right? Lock pages in memory we have to enable. How to enable? This is the same. Yes.
Can we identify is already locked?
Identify what?
How can we identify that whether it is a lock page manager is in our server?
And your voice is breaking and I cannot hear you. So you mean like how to enable whether the memory is streaming by so, or you're asking how to?
Yeah. Yes. How can we identify that our that server, which server we are looking for, that is enabled?
That is enabled. I'm taking you to. And if you go here, user rights and assignment, and the same thing, lock pages in memory. This is what you see.
Yes.
Lock pages in memory, and enable that service account here. Service account, and restart the SQL service. So that will be enabled. How to know whether the so memory is streaming or not? That is where you see here from the SQL error log. SQL error log, you will see that this amount of memory is paged out. The amount is paging out. So the amount is, so the memory is paging out. Those messages you will see in the SQL error log.
Okay.
Let's see if I have that. And that will be, so you will see that in the SQL error log. And from SQL error log also, you can see whether the lock pages is enabled or not. We will talk more. And this is one of the memory model. So if you see that conventional memory model or anything except lock pages in memory model, it is not used by the SQL server. SQL server is not using that memory lock pages in memory. It is a conventional memory model. So we will talk that conventional memory model, but to answer, to just give to see here, these messages you will see. a significant part of SQL Server process memory has been paged out. This may be result in performance degradation, right? So these kind of these messages you will see working set whatever it is. So if you are not enable the log pages in memory, then you will see these messages in the SQL Server error log if any of the memory which is allocated to SQL Server is trimming or paging out. So you will see these messages in the SQL error log.
So then what is the solution here?
That's what I was talking, right? So log pages in memory you'll have to enable.
Okay, okay.
Yeah, that is the solution that you have. So that
So we can
SQL will.
so Chandu, we can recommend to the customer, right? So this is the issue.
What is yeah. If you see that, and if so if any other process is consume memory, and if this is caused by the log by this process or due to the log pages in memory, either you can tell to the application, I mean definitely you'll have to inform to the application team, right? Because you'll have to restart the SQL instance. You cannot
Yes.
simply restart, you'll have to have a change control whatever it is, and you'll have to proceed the process, and you'll have to enable this and restart the SQL service. Yes.
Okay. Thank you.
Cool. And so TempDB configuration. So TempDB configuration is important because TempDB we all know it is a global database. If any of the misconfiguration of the TempDB, and you will end up seeing some slowness, right? So we will talk TempDB internals later, but TempDB is used by all of your databases and internal process, and everything will be used by the TempDB. So if you have any misconfiguration of the TempDB or any issues with the TempDB, you will end up seeing a slowness. So recent one occurrence, I was working, TempDB is full. TempDB we have a always on, and TempDB is full, right? Because of some versioning. So we will talk that so versioning and all. So TempDB it creates a versioning of your all the transactions, and TempDB is full. Because of that, we see huge lag or latency on in the always on, right? So as soon as we increase the TempDB size, that has fixed, right? So that is one of the example that we will talk so during TempDB internals, but TempDB is used for every transaction internal, so storing some internal temporary data or temporary result set. Even if you are doing some join operator, join, or even you are doing some sorting, order by, or anything you perform in SQL Server that uses TempDB in backend to store the temporary result set, so that you have to have a proper TempDB configurations. Trace flags to improve the performance, right? So trace flags also will be helpful to improve the performance. And remember these trace flags, I think these are all so older versions, like from starting from 2016. This might not be helpful. This might not be, these are the default tracing enabled in the SQL Server, right? So I just a high level, I'll touch base. Prevent mixed extents. So earlier versions, I mean earlier how we allocate the pages, right? Whenever you create a table, right? Create table, either it can be a temporary table or it can be a permanent table, persistent table. So if you create a table, then table requires few pages to store the data. So initially SQL Server allocates pages from the mixed extent. So mixed extent we know, right? Mixed extent we know. So each page can have a so from a different table altogether, right? It is a 64 KB of 8 pages, 8 into 8. This is an extent, and each extent will have a each page can be allocated to a different table altogether. The reason that we allocate to a mixed extent, the table can be a small. If it is a small, then there is no point of giving a uniform extent. If it is a uniform extent, what will happen? All 8 pages will be allocated to that particular table. If that is the case, if the table requires only 2 pages, the remaining 4 pages will be wasted, right? To avoid that, SQL engine by default will allocate only pages from the mixed extent, only allocated pages from the mixed extent, so that if it is only fit into a 2 pages, I mean table data fit into a 2 pages, the remaining pages will be allocated to the other another tables, right? But there is a downside of that. Downside is, this is good, right? So to maintain the space, to maintain the pages and all, this is good. But downside of it, whenever you create a table, it has to identify the mixed extent pages, the free space available, and the mixed extent, right? That is where you'll have to scan the GAM and SGAM. I'm not talking, is a internal pages SGAM, shared global allocation map. It has to scan, it has to identify that, so free space available in the extent, and it will be identify the page, identify the extent to allocate that page, allocate that extent to a created table, right? It is an expensive because it has to identify that, it has to scan the complete SGAM to get the page which is there, which is available, identify the mixed extent which is available. So it is an expensive. If that is the case, you will end up seeing some slowness during identifying that. To prevent that, we enable that 1118 trace flag. 1118, it will be allocating only from the uniform extent. Instead of mixed extent, it will be allocated all the pages, all 8 pages from only a uniform extent, instead of allocating from the mixed extent, right? So you are avoiding that. And auto growth. So whenever you have a data file, and you have a multiple data file, right? 1 or 2, 3, whatever it is. And if you are doing something on the data, on that particular data file, and if it is grown, if the file is grown, then remaining files we are leaving. If you are not increasing the file, I mean, if you are not growing the file, so one file will have more pages, the others will have a less pages. For example, the system pages, the amount of pages it has to access will be more, right? So the pages will be accessing more on only one file. Instead of that, what we do, so we want the equal increment of the files, right? Suppose if you are increasing 100 GB, then the equal amount of size has to be increased across all the files. That will take care by 1117. Suppose if the auto growth is enabled for 5 GB, and one file is out of space and it is increasing the 5 GB, then the other 2 files also will increase the same amount of space, so that we will avoid any latency while accessing only one particular page, right? So we are using multiple pages at the same time. And this trace flag, it was very helpful in the previous, so earlier versions. I think this is also included in starting from 2016. So let's say, for example, you are executing a query. If you are executing a query, and that is at timing out, optimizer timeout, or the query is running slow, right? Whatever reason, the query is running slow. And if that is the case, this will helpful. There are chances the query running slow because of some optimizer bugs also, right? Optimizer as in the query optimizer, the SQL Server engine bugs also. To fix that query optimizer bugs or fixes, then we enable trace flag 4199 to fix any of the query optimizer issues, right? So that you will avoid any timeout issues by the query optimizer. This is earlier version. So currently, I think this is also included in starting from 2016, but I see that people are still using, but that might not affect by enabling any of these trace flags, because the trace flags are by inbuilt starting from 2016. This is the basic configuration that we should be aware of. We should be knowing, we should be aware of. So any questions? Okay, so we'll move forward. So these are the few server wide configurations also you'll have to check, right? So let's say, for example, max server memory. If you don't provide the max memory, then how much SQL can utilize? So SQL cannot utilize whatever memory that we have, right? So on the server, so we have to restrict the max memory, or we have to provide some value to the max memory configuration, so that the memory will not be paced out. The like suppose, for example, the memory is completely growing and Windows needs some memory, then it will start trimming that memory, right? Instead of that, we leave the memory, some amount of memory to the SQL server, so that it will be dedicated to the SQL server, right? So the thumb rule of using memory is 80 and 20. So 80% out of memory we have, 80% allocate to the SQL server, and 20% memory leave it to the leave it to the Windows operating system, right? If it is 100 gigs, 80 gigs allocate to the SQL, 20 gigs for the to the operating system. So parallelism. So parallelism can be a good, can be bad, all right? So it can be good, it can be bad. The reason I said, let's say parallelism, what will happen if the query, if you're executing a query and if it needs 4 threads to execute, and I have 4 CPUs. Let's take a simple example. 4 threads and 4 CPUs, and each thread will go ahead and execute on each individual CPU, right? So each thread will execute an individual CPU. If you have more threads are created, or if you have more queries which are created, then those threads will be in the queue on individual CPU queues, right? So in individual CPU, it will be in the queue. If this query is running slow, if the query is running slow, then what will happen? You will see high CPU utilization because of, so the query is running slow, and you will see the performance issues, right? So if the query is running slow, so how this works, each thread running on individual CPU. So each thread will take same amount of CPU cycles, right? If the thread is running slow, and if each thread is taking 100 milliseconds, 100 cycles of CPU, 100 millisecond, then each thread will take the same amount of CPU. If that is the case, one thread is slow, the other threads will be slow. One thread is taking, so 10% of CPU, the other threads also will be taking the same amount of CPU, right? So if it is 10%, this will be 10%, this will be 10%, this will be 10%, right? Likewise, you will end up seeing a high CPU utilization because of parallel execution. So we will talk that in the query performance, right? So this is a high level. If you see any query running parallelly, that is any query you see that you see any high CPU utilization, and you notice that query parallel execution, that is one of the contributor for high CPU utilization. But at the same time, the parallel execution can improve the performance of your query. Let's say your query is executing 10 minutes with a single thread, and this query can be faster if you split this thread into multiple CPUs. If that split this query across multiple CPUs, right? So you will have that execution faster, and you will have the same, you will have the slower execution as well. Slower execution because you have 4 CPUs and executing threads. Let's say one thread is executing and which is running slow, then the remaining thread also has to wait for the thread to be completed, the execution of the thread to be completed, right? So that is the reason, if the query is running slow, this is also one of the contributor for the slow execution, parallelism. Query optimizer for ad hoc workload. So we know ad hoc workload, right? So ad hoc workload is, for example, it is not a parameterization, or it is not a stored procedure. it is not a repetitive queries, right? We are executing ad hoc queries and we are destroying them, right? So let's say, for example, select star from table where ID equal to 100. Select star from table where ID equal to 200. So these are all ad hoc queries, right? We are not parameterized. These are all ad hoc queries. If that is the case, the query, what will happen? Plan cache we have, right? So each query will store the plan in the plan cache, right? If you're executing likewise, if you're executing hundreds of queries, ad hoc queries, SQL Server cannot cache or cannot store the plans in the plan cache, right? So it will be, plan cache will be bloated. Plan cache will be in a huge size. To avoid that, we can enable optimizer for ad hoc workload. How this works? Let's say you are executing a simple query. I'll show you that. Select star from a simple transaction I'm executing. So if you're executing 100, let's say, if you're executing this query, this we consider as an ad hoc. If you're executing this query, the plan will be generated. And if you execute another query with this, another plan will be generated. So instead of that, what will happen? Because this is not a parameterized. Parameterized is something that you have that stored procedure or so dynamic SQL where you provide that auto parameterization and all. So this is not a parameterized. This is just individual query that you are executing. So each query will have its own execution plan. So if that is the case, if you have executed thousands of connections or thousands of queries like this, so SQL Server has to store each execution plan. It also requires some amount of memory to store. So if you are storing such huge transactions or huge queries, then the query plan, the plan cache will be increasing. The plan cache, if it is plan cache is increasing, the size will be bloated. Let's say, for example, GB. You given for max memory. This max memory is divided across multiple memory parts in SQL Server. One is this buffer pool. One part is buffer pool. Buffer pool is to store your data and index pages. Second one is plan cache. Plan cache is to store your execution plans, right? So if you are giving this 10 GB only, if your plan cache is 2 GB, 3 GB, then the remaining 7 GB is for other memory areas. One is data and index pages, data cache, right? If it is keep increasing, the data and index pages will be removed from the memory and will be allocating that memory to the plan cache. That will be impacting while require pages to read. So you will have to read from the disk. That is very expensive instead of creating a plan, right? Optimizer creates a plan very quick, right? It is within seconds, it creates a plan. But getting the data from the data file is much more expensive. So that is the reason we should have always consider, so creating consider maintaining a better execution plan cache. So that is the reason you always use, you might have used that DBCC free pro cache. So what it does, it will remove the plans from the cache, right? We will talk if you are not aware, or I assume that you might have already aware of this, but we will definitely talk in detail in the memory discussion. But here, if you execute this, it will remove the plans. The reason that we have is creating a plan is an optimizer task, and it would be much more faster than reading data from the data file. We have another one, DBCC drop clean buffers. This also, it will be removed the clean pages from the memory. If you are executing this, then again, whatever data and index pages that we have will be removed from the memory and will be moved to the data file, right? So make sure that you don't execute DBCC drop clean buffers. It will be removed data pages. And if you execute DBCC free pro cache, this is somewhat okay. But if it is very highly transactional database, and if you execute this, it will leads to excessive compilations, because if you remove the plan, it will go for again compile the plan and get the execution of the query. So what will happen if you keep writing into the ad hoc plans to the plan cache? To avoid that, what we have, so we have a optimizer for ad hoc queries, right? If you go here, go to the instance level properties and go to that advanced, you see that optimizer for ad hoc workload. Sorry. You will have to turn it on, right? If you set it to true, then what will happen? This will be creating a plan. Now, this will not create, I mean, this will not store the entire plan of this query. So instead, it creates a stub, right? It creates a stub of this query. Okay. Stub. So what is that stub? So instead of creating the entire plan and storing, so it creates just a small, so entry, right? So it is in just a 2 or 3 bytes, even very small entry stored in the memory, right? Entry stored in the plan cache and stating that this is the stub of this query. This stub is nothing but just a piece of plan will be stored in the memory. Then if the same query or similar query executes next time, then this stub will be converted into a plan. So first it will store that stub of this plan in the memory. And if the similar query executes, it identifies that yes, this query is reusing query, right? So that is what we have, that store procedure. Store procedure is for reusability. If the query is reusing, so that plan might be required to reuse. So this stub will be converted into the plan, and that plan will be stored in the plan cache. This stub will be removed from the plan cache, right? The stub will be converted as a plan, and plan will be stored in the plan cache. That is the advantage by enabling this optimizer for ad hoc workload, right? If you have a excessive ad hoc queries, and if you are doing this, then you'll have to identify, you'll have to enable that. How to identify that either it is an ad hoc plan or it is a it is a stored procedure or some, so object plan, right? So you have something called DBCC. We will talk, don't worry, DBCC. What we call DBCC. Okay, fine. Select start from sys.dm underscore exec dm underscore memory clerks sys.dm underscore db sorry, db whatever, like memory clerks that we status. Not status, not broker, memory clerks. Yeah. So this is .dm underscore os memory clerks. Okay, so I was talking DBCC memory status, right? So if you execute DBCC memory status or DBCC DMOS memory clerks, we have something called so these are all we will talk in detail. So just I'll show you, so how to identify that cached plans, or so how to identify that ad hoc memory is taking most of the memory you have. Okay, so here if you see that It is that SQL CP and object CP. Cache store, SQL CP and objects CP. So these you will tell if SQL CP is high, this is what you see, the ad hoc plans are high, right? Pages allocated. So currently, if you see the SQL CP is the pages allocated is 21 MB, right? So this is the MB like calculation, right? So if you see that divide into 3 is considered as a MB, right? 1024. This is the object CP where you store that the so procedure plan, right? So if you have a procedures or functions, whatever it is, that plans will be stored as an object CP. If it is an ad hoc queries, and it will be stored in the SQL CP. That is where you will have to identify whether you have a high ad hoc workload or not, right? From there, you have to make sure that you enable what is that? You enable optimizer for ad hoc to improve to avoid that ad hoc plan cache, right? So where memory clerk name like SQL CP. Like for example, this is one of the not type name type. Right. So this is what you see SQL CP, right? So you will have to identify what is the memory allocated for this particular clerk, so that you will identify this is the ad hoc clerk that is taking most of the memory, right? So these are all some configurations. So database wide, also you'll have to make sure that so you have a proper configuration, like let's say disable auto shrink. So auto shrink should not be enabled, right? So that we will have to make sure, and disable auto close. Suppose if you have any so auto close enable at the database level, right? You'll have to make sure that you remove that. Recovery model also will be helpful, so that you would be able to recover the data. So point in time recovery would be happen, like you'll have to have a proper recovery model that you have. Compatibility level, right? So the database compatibility level, let's say for example you upgrade from 2012 to 2019 or 2017 or 2016, whatever it is. If you are upgrading from lower version to the higher version, and to so I mean make sure if you upgrade from lower version to the higher version, to upgrade the database, I mean if the database affect any of the new configurations, to affect any of the new configuration or features, we'll have to change the database compatibility level based on the version that we upgraded, so that whatever new features that we have, that will be available for that particular database, right? So let's say you have 120 and 140, right? 120 is for 2014 and 140 is for 2017, right? So if you upgrade the database, you'll have to change the database compatibility level. That is the properties and option, and this is what the compatibility level is. Whatever version that you upgrade, you'll have to have a proper compatibility level, so that whatever new features that I have in the latest version will be affected and applicable to that particular database, right? That also one of the consideration that you'll have to consider when you are doing a performance tuning. And virtual log file, VLF. So we know that virtual log file is further divided into multiple virtual log file. Whenever a recovery happens, you are restarting the SQL server. Whenever recovery happens, the recovery will be scanning through the complete log file to identify from where the recovery should process, right? From where the recovery should process. If you have a huge log file, or if you have a huge VLFs, the amount of time it bring the database online would be much more longer, right? So that you will have to have a proper VLFs. I mean, you will have to have a proper auto growth and initial size of the transaction log file to restrict the number of VLFs, right? If you have huge VLFs, then the recovery, it has to identify that where the last checkpoint, and from there it has to try to scan that complete VLF, complete transaction log file to proceed the recovery, right? So if your database is recovering and if it is taking more time, this is also one of the contributor for slow recovery. Second thing, unnecessary monitoring, which impacts the performance. So what does it mean? I was working on, I'll tell you a live example. Like I was working on one issue, right? So they mention one query, a specific simple query, select query, or whatever query that they're executing, running faster in one server and slower in another server, right? So running faster in one server and slow in another server. So we noticed no difference, right? We don't see any difference in execution, or we don't see any difference in the plan. We don't see any difference in the configuration, nothing. So we don't see any difference in their environment. Both servers are identical without any difference. Further investigation. So, I mean, we had to capture some internal debugging traces and all. In the further investigation, we identified, I mean, randomly I was checking, right? So we couldn't find anything, and randomly I was checking, and one server, they have some monitoring extended events enabled in the SQL server. So SQL server, there is an extended events session capture enabled. What exactly that is doing? That is scanning the plans, execution plans, and storing the execution plans. If you are capturing the statement level, that's fine. But if you are capturing that execution plan and storing that execution plan, that is what we notice some latency, because it has to identify and scanning the execution plan and store that execution plan. That is what we notice the slowness. As soon as we disable that, and the query executed the same amount of time on both the servers, right? So external events, enabling external events is not an issue, but what data we are capturing in the external events is matters, right? If you are capturing that execution plan, if you are running the batch, huge batch, which has so many queries, right? If that is the case, it can start capturing the execution plan of each statement that we have. So make sure that we are not capturing any of the execution plan of your queries, right? So that is few basic configuration that we will have to look into, right? So I will just touch base on this, and we'll wind up for today. So any questions that you have till now? Any questions so far? This is I might be a little faster. I assume that you all know these things. This is just a high level configuration wise. This is not anything specific to performance or anything. This is just a overall configuration on the server which you should be aware of. But yeah, if you have any questions, or if you feel that it was fast, so that I can try to explain in detail, so if you need anything on the anything specific.
Yeah, I have a quick question.
Mhm.
Let's say we have an issue on an instance, and you want to check your error log, and it's a very high transitional instance, which means it's going to have a lot of information in error logs.
Correct.
So let's say you run SP read error log the way you ran it earlier, and you want to filter just a day or 2 days. How do you pass the parameter to give you the exact of what you are looking for?
Okay, so if you execute read error log, it executes and read data from the recent error log, whatever data file, whatever error log file you have. So it will be reading from the recent error log. So you can pass parameters, for example, 0, 1. So this is 0th file, and this is the first file. First file is nothing but your error log file. So if you change it to 2, you will get it from the SQL agent log. Right, so 1 is for the SQL error log, 2 is for the SQL error agent log. This is just a high level that I believe that you might be interested or would like. So this is for the error agent, SQL agent, and this is for SQL error log. I am concentrating on error log. So if I execute this is the recent error log file, and you will get the recent data. At the same time, if you use 1, that is the previous error log. The same time, if you use 2, that is the next previous to previous error log. So likewise, you can enable, you can execute, I mean, until the maximum error log limit, you can get that. Suppose if I have 14, I don't know whether I have enabled. So you don't have this 14, right? By default, it will be 6 or 7 files will be created. So you will have that 7 files, it will be by default. And so I need, so I can convert this into text format, right? So if you click here, Control T or this highlight this one, and it will be going into the text format. Now I want to filter only some amount of some piece of information. For example, parallel redo, right? Whatever I want to filter. So you can just comma and single quotation and use this parallel redo, and you get whatever, you know, so filtering whatever data we have by matching this value, you can get that information. Parallel
Thank
redo.
you.
So whatever you can get that. This is what you're asking?
Yeah, Grace.
Cool.
Thank you.
Sure, no problem. And just for your information, might be you are aware or not, but doesn't matter. But if you have whatever SQL error log, and you can configure that SQL error log, the limit, right? So you can configure maximum up to 99 SQL error log files, right? So you can see here, value must be 6 and 99. So the minimum value is 6. That is your 0 to 6, total 7 files. It is a 99. That is 0 to 99. That is total 100 files, right? So you can limit the number of error log files as well. But that is based on, you know, so the environment and the servers that you configure. Yeah, this is how you can configure. By default, it will be 7 files will be created.
Thank you.
Good. And I'll just you know, so okay, so question to you, right? So let's say users are complaining some slowness. So I am a user, you know, so the server is slow. I mean, I not server, so I'm telling that slow. So what questions you ask, and how you will investigate further, you know, so how to narrow down or how to investigate further. So there is a slowness, right? What are all questions that you ask, or how to how proceed further? You will directly go ahead and execute something on the database and you know, so share that information, or how you will proceed further.
You need to know, you need to ask which server.
Server name,
First.
okay.
Yeah.
And
And
okay, so environment details, I'll ask like whatever details, like I have server name, the version, like whatever, like, you know, so you have that we will ask, and I just consolidated as an environment details. What else?
yeah, and then you want to ask previously, how long does it take, just to give you a clue that truly it's running slow.
Exactly what we consider that baseline of the execution. So what do you mean by baseline? Is the previously, what is the, you know, so baseline of this execution? Let's say the query is running slow. Let's take an example. If the query is running slow, what do you mean by slow? So 1 hour is not slow for me, but one minute is slow, you know, so based on your environment, right? So you should have a baseline. So you should have that baseline to say that it is slow or not, right? So that baseline is what you said is a previous execution history. Let's say query is running slow, or the queries are running slow. If that is the case, what is the ideal time to execute the query? So what was the previous execution history? Let's say the previous query executed in 1 second. Now query is taking 1 minute. Is the latency. So 1 second is the baseline, and 1 minute is the current execution. So based on this, we'll have to check what best we can do. So then what? Good point. So you should have a baseline to this is the first point. I mean, definitely you'll have to have more details, like you will have to understand the baseline of the execution to proceed further. So what else you ask?
If it is like a stop procedure, you want to know if it's recently modified, there's anything that has changed in it.
Right, great. So any modifications, right? So any modifications of the query or application side or anything, so which we have to notice, right? So any modification that are done. Cool. What else? Anything? How long? So how long you see this behavior, right? So like, let's say for example, like it's been like 1 hour before or 2 hours before or 3 hours before or even 1 day before or 2 days before. So if you know that, at least it helps for us to investigate or start investigating from that point. Let's say for example, the query is running slow from last 1 hour. I'll tell you one live example, right? So I got a so issue, right? So that query is running slow from 3 a.m. some whatever time zone it is, 3 a.m. So they're telling that it has been running slow from 3 a.m. So it's been whatever, like, so the query is running slow from 3 years, and each query is running, I mean, the same query runs hundreds of times, right? So if each query is running slow, then 100 queries will be slower, right? The query started running slow from 3 a.m. I asked, like, since when they noticed some issue, this issue. Since, so starting from 3 a.m. they started seeing slowness. And what I was checking, so I checked like what was running before 3 a.m. right? What was running before 3 a.m. or what ran exact 3 a.m. Then I noticed, right? So I noticed some maintenance activities, right? Re-indexing and update stats executed at 3 a.m. What it exactly does, right? It will remove the plans from the plan cache. It will make sure that the plans are removed, and it will be recompile the plan. I mean, the plans will be removed by, if you are doing any maintenance like alter, update statistics or re-indexing, it will remove the plan and a new plan will be created for the queries, right? So earlier the plans which they were executing was better plan, and after recompilation, after the compile, those are the bad query execution plans. Because of that, all the plans are, so all the queries are waiting for some resources and going for a poor execution and all. And that I noticed from the query store. Query store, I noticed the previous plan and the current plan, and I had to force the plan so that the query started executing faster. So we will talk that query store, but just a high level. So you'll have to identify how long the query is running slow, right? So yeah, there are many, there are other that based on, so the situation, that the issue that we will have to discuss, right? So that is what I mentioned here. What performance problem? Show me your baseline, right? So we'll have to identify the baseline. No baseline, no performance problems, right? So if you don't have a baseline of your query, I don't know, right? So 1 minute, as I said before, 1 minute is slower for you. 1 hour is slow for me. 1 hour is faster for me, right? It all depends on your perspective and the way that you started investigating the issue, right? So that is the reason we should have a baseline of the execution. If they have some metrics, well and good. If they don't, we will see what best we can do from our end, right? Metrics as in like they have some plans or they have some old history, application team or whoever it. So if that is the case, then it is well and good, right? We can just compare the execution plans and understand the slowness. If they don't, from SQL Server side, we'll expect, so just give our expectations, set expectations that we can do our best from SQL Server side. If anything needed, maybe they'll have to fine tune their queries, right? So that is what it is. Yeah.
In
So I don't even understand. So this is only for me or for others also? Because your voice is too low, like your voice is too low, or your voice.
I can't hear him. I think it's for everybody.
Yeah, that's what. I cannot hear you, Arya. Okay. Yeah, we'll talk if anything needed. But yeah, this is what we thought of discussing here, right? So tomorrow's session. So we'll talk. This is what we already know. right? So if the session is waiting for, then it is called a suspend and all. And we will discuss few wait types that we have, right? So running and waiting, what is the difference between run and wait, and what are the wait types that we have? So we will talk few wait types, right? So what we have in majorly, so in the SQL Server, we end up saying that, right? So we will discuss.
I think he sent his question on the chat already.
Is benchmarking is also same like baseline? Yeah, same. Benchmark. So what do you mean by benchmark? So that baseline is like, so whatever they have that, right? So whatever baseline that they have, so the previous execution, so that based on that, we will have to, so investigate and identify the issue, right? So benchmark. So benchmark, I don't know what does it mean. Benchmark is maximum of this query. Let's say, for example, the query has to execute in 5 minutes. That is your benchmark, or that is your benchmark, right? So that has to execute in 5 minutes. But the baseline is the query execution is 3 minutes, and now it is taking more time, right? So benchmark is the maximum time duration that it takes. Baseline is the previous execution it executed on this server. Right? So benchmark can be anything, right? But baseline you should have, so that based on the baseline, you will understand that this is the baseline of this query. Earlier it used to execute in 5 minutes. Now it is taking so much time. Right. So we will discuss, so few like weight types. We will discuss like weight types, and so what is the how to what are the DMVs that we have to identify the weight statistics, weight information and all in tomorrow's class. So any questions? I'll stop here. So performance monitor we can use, but not everything. We can use a high level. For example, CPU metrics, we can identify which process is consuming most of the CPU, but you cannot tell which query is running, which query is contributing, or what in that process is contributing most of the CPU. You cannot do. So you cannot identify all the metrics, but only certain things. For memory, let's say for example, memory, which process, which so clerk, like we call it as a clerks, we will talk that later. But memory, we can identify which clerk is consuming most of the memory. So that high level, what are all available in the performance monitor, that you can identify, and you can find that information. Let's say for example, memory plan cache, right? So if that is the case, you can identify from the performance monitor. Anything relevant or only for the SQL related stuff, you cannot identify. Like say for example, queries that you cannot find. So let's say you have some execution slow that you cannot find. You cannot find in the query, that you cannot find in the performance monitor. So only the instance level or high level you can identify from the performance monitor. Okay, I'll stop questions here as well, because it's too late for so for the people like who are in US. So any questions, or we'll wind up for today and we'll connect tomorrow. I'll stop recording.